is Lee Mi-wen. My metric number is 22302410. Today I'll be introducing our explore of plant diversity around the campus, which is an understanding of a specific phyla, which is pteridophytes. Also, an on-site research is conducted to locate and identify pteridophytes, which is in example shown later. This research has aimed to foster a deeper appreciation for plant biodiversity and its significance in conservation efforts. Pteridophytes. Pteridophyte is regarded as the most primitive vascular plants, feature a straightforward reproductive system without flower and seeds. They evolve a system of xylem and phloem which enabled them to surpass the limitation of their non-vascular ancestors, facilitating greater heights and thus enhancing spore dispersal, which in turn foster the growth of new plants. The primary characteristic of pteridophytes are seedless, vascular plants that show true alternation of generation. The sporophyte, which is one of the alternation of generation, is in diploid phase, has true roots, stem, and leaf. Also, the spores, which is in haploid phase, are produced and developed in mature in unique cells, capsules known as sporangium. In other words, they help the organism to reproduce. At last, pteridophytes can be either homosporous or heterosporous. Thank you.
The first ecological significance of pteridophytes is that they often create habitat for small organisms like millipede arthropods, their larvae, bacteria, and cyanobacteria. This is because the large, often complex leaves called fronds provide an extensive surface area, which creating microhabitats for these small organisms. The complex structure of fronds often traps moisture and organic debris, creating a suitable environment for colonization by various organisms. Second ecological significance is that pteridophytes frequently act as pioneer species in disturbed environments such as landslides, abandoned fields, or forest clearings, where they swiftly establish themselves. Many pteridophytes have adaptations that allow them to thrive in challenging environmental conditions, such as poor soil quality, high levels of sunlight, or low water availability. These adaptations enable them to colonize habitats where other plants may struggle to survive. This rapid colonization aids in the establishment of diverse plant species, which then enhancing ecosystem biodiversity and stability.
Good day, doctor. My name is Anna Lu, and now I'm going to discuss the importance of conservation of pteridophyte in the field of medical, economic, and ecological roles. Pteridophyte hold significant medical and economic value due to their rich repository of bioactive compounds with therapeutic potential and their contribution to various industries. These plants, with their historical use in traditional medic and ongoing research interests, offer promising avenue for drug discovery in treating conditions like cancer, inflammation, and more. The cultivation and sustainable composting not only support the pharmaceutical sector but also contribute to local economics. In ecological roles, peridophytes play vital ecological role, especially in soil stabilization, nutrient cycling, and habitat correction. The robust root system and dense foliage contribute significant to prevent soil erosion, especially in sensitive areas like riverbank and slope, by anchoring soil and reducing erosion caused by water runoff.
Good morning. My name is Eunice Ng, matrix number 2230234, and I'll be presenting about the 6 ferns found in USM campus. The first fern is under the genus Asplenium, and it has the name bird's nest fern, scientific name Asplenium nidus. The second and third ferns are under the genus Aglomorpha. Second fern has the name Gusuibu, which has scientific name Aglomorpha fortunae. And the third fern is oak leaf fern with scientific name Aglomorpha quercifolia. Fourth and fifth ferns are found under genus Pyrosia. The fourth fern is dragon scales, which has scientific name Pyrosia pilocelodes. And the fifth fern is long-leaf felt fern with scientific name Pyrosia longifolia. Sixth fern is under the genus Nephrotapis, and it is the giant sword fern with scientific name Nephrotapis bisurata. One of the first few ferns that we found in USM campus include bird's nest fern with the scientific name Asplenium nidus. The bird's nest fern prefers habitats with warm temperatures and high humidity levels, which explains why they thrive in areas and prefer tropical and subtropical climates with consistent warmth and humidity. They also thrive in areas with indirect sunlight and well-drained nutrient-rich soil, and their ideal locations for growth include rainforests where they can be found growing on trees, rocks, or even on the forest floor with areas with sufficient moisture and shade. Their growth characteristics include slow-growing fern in the Spleenworth family, and it is generally slow-growing and can eventually reach impressive sizes with fronds extending several feet in length. And another characteristic is that they reproduce via spores, which are produced on the underside of the fronds in structures called sori. One of the notable features about bird's nest fern is its large, wavy, bright green fronds, which form a rosette shape resembling a bird's nest, hence their name, bird's nest fern. And it also has epiphytic lifestyle, which means that they grow on other plants or structures, but they are not parasitic and do not harm their hosts. And it has sori arranged in rows along midrib or frond edges, and this arrangement is an important diagnostic feature for identifying these species. Its ecological role is its unique frond structure which aids in moisture retention, which creates a microhabitat for forest biodiversity. As epiphytes, bird's nest ferns play a crucial role in their ecosystems by providing habitat and shelter for a variety of organisms including insects, small reptiles, and amphibians. Their presence also helps to stabilize the soil and to prevent soil erosion, particularly in areas with steep terrain. The bird's nest fern contribute to the overall aesthetics and biodiversity of their habitats, aiding to the beauty and complexity of forests. Next, I will continue with two ferns from the genus Aglomorpha. First is Aglomorpha fortunei, known as Gusuibu, and the second is Aglomorpha quercifolia, which is known as oak leaf fern. Gusuibu is larger in size, have thicker leaves, and its sori are found on both sides of the central rib of a fertile foliage frond. On the other hand, oak leaf fern is smaller in size, have thinner leaves, and its sori are found on the undersides of the fronds. Both share similarities in climate. Both species thrive in tropical climates. Both are epiphytes, meaning that they grow on other plants but are not parasitic. Both species have similar frond structures despite their size and leaf thickness differences, and both prefer shaded, moist environments typical of tropical regions. Aglomorpha fortunei, known as gusuibu, is used in Chinese herbal medicine for its purported health benefits, and it has larger and thicker leaves, suggesting that it may be more adapted to capturing and storing moisture, possibly indicating a preference for slightly drier conditions within the tropical environment. On the other hand, Aglomorpha crassifolia is smaller size and thinner leaves, may suggest requiring higher humidity levels or more protection from direct sunlight. The placement of sori on the undersides of the fronds in oak leaf fern is a common adaptation, helping to protect the spores from drying out and aiding in their dispersal.
Hello doctor, my name is Drawling, which number is 231019141. Firstly, I will introduce two types of ferns from Pyrosia. First one is Pyrosia piloceloid, dragon's gate, and the second one is Pyrosia longifolia, long-leaf fern. Dragon's gate is round, fleshless or scragulent leaves. Dimorphic fronds, sorry produced near the margins of fertile ground, and long-leaf fell-furries, stem-struck stripe, elongate from monomorphic fronds, soaring near the tips of fronds on the underside. Their similarity are both located in the tropical area with indirect sunlight, moist environment, and they are both epiphytic ferns, have long sculpting rhizomes, commensal commensal relationship with host tree, and mortality relationship with other epiphytes. Next, I will continue with Nephilophys becerrula, giant scoffers located on USM campus. Firstly, these prefer to grow in rock crevices or tree trunk near foreign streams and prefer warm humid conditions. Secondly, these fur upright rootstock and leaf blades narrow and long. Then it appears to have leaf blades margins are scute and leaf widths are compressed. Finally, it can retain sun and water, provide habitation for other organisms, and it is an important component of biodiversity in ecosystem.
Good morning, everyone. My name is Eunice Ang with metric number 22302949. In conclusion, pteridophytes are seedless plants that reproduce by spores and show through alteration of generations. They have true roots, stems, and live in their sporophyte generation. Pteridophytes typically inhabit moist environments with indirect sunlight and tropical climates. They are epiphytes that grow on their host plant without harming the host plant, and this is known as commensalism. They also exhibit mutualism with other epiphytes by providing nutrients and water. The examples of pteridophytes include Asplenium nidus, which is the birdnest fern, the Agalmorpha species, which includes Agalmorpha fortunei and Agalmorpha crassifolia, and the Pyrosia species like Pyrosia pilecelluloides and Pyrosia longifolia, and the Nephrothepis bicerate. Pteridophytes play a significant role in the ecological processes such as promoting efficient nutrient cycling. They often act as the pioneer species in their habitat and considered as the first plants to be evolved on land. Pteridophytes also provide habitat and nesting sites for small organisms such as arthropods. Besides, they also can be used as medicine to cure disease. Thus, it is very important to conserve this type of plant to maintain the balance of the ecosystem and to explore its uses in various fields. However, human activities like residential development, pollution, deforestation, and climate change are threats to plant biodiversity and cause the decrease in the number of pteridophytes. Therefore, we need to put efforts in conserving this type of plants by various methods such as establishing national parks and reserves, restricting urban and industrial development, carrying out breeding programs, and establishing the seed banks to maintain the high biodiversity. Thank you.